Let's talk more about the two-sample t-test, since we'll want to compare two different samples in our class project. There are a few different versions of the t-test that one might employ, and they depend really on what assumptions we make about the data. So we might want to ask questions such as, do our samples have the same size, and do they have the same variance? Let's discuss a variant of the t-test called Welch's t-test in more depth, since it's the most general. It doesn't assume equal sample size or equal variance. In Welch's t-test, we compute a t-statistic using the following equation. T equals mu1 minus mu2 divided by the square root of sigma 1 squared over n1 plus sigma 2 squared over n2, where mu I is the sample mean for the ith sample, sigma squared I is the sample variance for the ith sample, and ni is the sample size for the ith sample. We'll also want to estimate the number of degrees of freedom, nu, using the following equation. Nu is approximately equal to quantity sigma 1 squared over n1 plus sigma 2 squared over n2 squared over sigma 1 to the fourth over n1 squared nu 1 plus sigma 2 to the fourth over n2 squared nu 2, where mu I is equal to ni minus 1, and this is the degrees of freedom associated with the ith variance estimate. If you're unfamiliar with degrees of freedom, again, it might be a good idea to brush up on your stats concepts with Udacity's Intro to Stats course. A link is provided in the instructor comments. Alright, so once we have these two values, we can estimate the p-value. Conceptually, the p-value is the probability of obtaining a test statistic at least as extreme as the one that was actually observed, assuming that the null hypothesis was true. The p-value is not the probability that the null hypothesis is true given the data. So again, just as a thought experiment, say we were testing whether left-handed or right-handed baseball players were better batters by looking at their average batting average. If the p-value was 0.05, this would mean that even if there's no difference between left-handed and right-handed batters, since that's our null hypothesis, so even if this was true, we would see a value of t equal or greater to the one that we saw 5% of the time. When performing a statistical test like this, we usually set some critical value of p. Let's call it p critical. If p falls below p critical, then we would reject the null hypothesis. In the two-sample case, this is equivalent to stating that the mean for our two samples is not equal. Calculating this p-value for a given set of data can be kind of tedious. Thankfully, we seldom have to perform this calculation explicitly.